The indications for the engine oil system are displayed on the secondary engine display. Select the secondary engine indications to the lower center MFD. Engine oil pressure is measured in PSI. Oil temperature is in degrees Celsius. Oil quantity is displayed to the nearest liter. As with other engine indicators, if a sensor signal is not present or invalid, the respective indicator is blanked. The operating limits for oil pressure and temperature are shown here in red. Oil pressure and temperature also display a lower amber caution range. There is no minimum oil quantity limit displayed on the indicator. However, a low oil quantity displays with a white background and a low indication. Like the amber and red line conditions, this low indication causes automatic display of the secondary engine indications. Now, let's look at how these indications relate to the self-contained engine oil system. Sensors in the reservoir measure the oil quantity. An engine-driven oil pump pressurizes oil from the reservoir. Solid contaminants are removed by a high-pressure oil filter. As the oil flows through the two oil coolers, it is first cooled by air and then by fuel. The fuel oil heat exchanger is the primary source of oil cooling. It also provides automatic fuel heat to prevent fuel icing. Oil pressure is measured prior to entering the engine. The oil then lubricates and cools the engine main bearings, gears, and accessory drives. After lubricating and cooling the gearbox, the oil is returned to the reservoir through a scavenge pump and a scavenge oil filter. If the scavenge oil filter becomes clogged, the oil automatically bypasses the filter. Oil temperature is sensed before the oil reaches the reservoir. Controls for the engine fuel system are located here on the control stand. Each engine fuel control switch has two positions, run and cutoff. In the cutoff position, the spar and engine fuel valves are closed, preventing fuel from entering the engine. Engine ignition is also deactivated. Move the left fuel control switch to run. Positioning the fuel control switch to run opens the spar valve and enables the EEC to open the engine valve and activate ignition. Fuel flows through the spar valve to the first stage engine fuel pump, which increases the fuel pressure. Next, the fuel is heated by the fuel oil heat exchanger. This provides automatic fuel system icing protection. The fuel then passes through a filter to remove solid contaminants. If the fuel filter becomes clogged, the fuel automatically bypasses the filter. The second stage pump then adds additional pressure to the fuel as it enters the fuel metering unit. The fuel metering unit adjusts fuel flow to meet thrust requirements as commanded by the EEC and thrust levers. The fuel then flows through the engine fuel valve into the engine. Fuel flow is measured after passing through the engine fuel valve. Fuel flow is displayed in thousands of kilograms per hour. The airborne vibration monitoring system monitors engine vibration levels to track rotor imbalance. The system determines which rotor is producing the highest vibration. Vibration level is displayed here in units. An annunciator indicates whether N1, N2, or N3 is the source of the highest vibration. If the vibration source cannot be determined, broadband vibration is indicated. Broadband vibration is the average vibration detected. There is no certified vibration limit, therefore, there is no amber or red line limit displayed on the indicator. However, if the vibration level reaches the white tick mark, the engine vibration is displayed with a white background. Like the low oil indication, a high vibration causes automatic display of the secondary engine indications. Now let's look at some non-normal situations starting with the oil system. If oil pressure falls below the red line limit, the pointer, digits, and box turn red. The ICAS caution message, engine oil pressure, appears for the associated engine, indicating low oil pressure. Since engine damage or failure is possible, the engine should be shut down. If the oil temperature reaches the red line limit, the pointer, digits, and box turn red, and the ICAS advisory message, engine oil temperature, displays. Since engine damage or failure is possible with high oil temperature, the engine may have to be shut down if the condition continues. Now let's look at some non-normal conditions in the fuel system. Use the right engine fuel control switch to open the spar and engine fuel valves. If a spar or engine fuel valve does not reach the commanded position, the ICAS advisory message, engine fuel valve for the associated engine, displays. If this message appears during engine start, as in this example, the engine will not start. Now let's use an engine shutdown example. Move the right fuel control switch to cutoff. The engine fuel valve has failed to close. The engine will continue to run for 7 minutes until the remaining fuel has been burned.